Okay, new video. So starting with C. This one's pretty tricky. Something to remember with this one is that I'm looking inside the parentheses here and I'm seeing there is subtraction and addition. So I'm not allowed to distribute this exponent inside the parentheses. Can't do it. Instead, let's see what we can do working inside the parentheses here. Let's see if we can kind of manipulate that expression. So as we're looking at this is super tricky to see, but this is kind of like a fake quadratic. So you guys might remember back when we did our factoring crash course, we talked about expressions, trinomials, so things with three terms that act like quadratics but aren't quadratics. And they act like quadratics in that they can actually be factored. So I want you to think about this. This is actually a factorable trinomial. What we want to do is we want to come up with two things that are going to multiply to A, two things that are going to multiply to B, and thinking about that middle term, somehow we have to get our terms to add to -2 root AB, all right? Here's how we actually do this. Two things that multiply to A would be root A and root A. So I can factor this, root A, root A. Two things that multiply to B, root B and root B. And now think about how you're going to get that middle term, -2 root AB. If you make both of these negative, this is going to work out. Root A times root A will give you A. Root A times -B will give you negative root AB. And then again, negative root B times root A is going to give you negative root AB, which combining like terms will give you this. Negative root B times negative root B is positive B. Now remember, all of this gets raised to the power of 1/2. Okay, well here's the thing about that trinomial that we just factored. Notice that these factors are repeated, which means they can be consolidated. And this can become root A minus root B squared, and then all that gets raised to the 1/2, all right? Well, power to a power, 2 times 1/2 is just 1, and so our final answer is just going to be square root of A minus square root of B to the first, or just square root of A minus square root of B. That's a tricky one, but it's essentially a fake quadratic there. Moving to D. Okay, so moving to D, again, there's addition here. You are not allowed to distribute that exponent into the parentheses, so instead work inside the parentheses first and manipulate what you see. So 3 to the -2, if I want to write that with a positive exponent, that's actually 1/3 to the +2. Likewise, 4 to the -2 would be 1/4 to the +2. So I can turn negative exponents into positive exponents by essentially creating a fraction and dropping what I see to the denominator, making the power positive. All that is still raised to the 1/2. From here, I have 1/9 plus 1/16 to the 1/2. And let's see, if I can get a common denominator here, I should be able to combine those fractions. So what would a common denominator be for 9 and 16? It's 16 times 9. 16 times 9 is 144. Let's make that our common denominator. Okay, so if I want to make our common denominator 144, I had to multiply 9 by 16 to get there, so that's 16 1/44. And likewise, I multiplied this by 9 to get 144, so that's 9/144. Now with the common denominator, we can add these things together, so we get 25/144 raised to the 1/2. So nice that both of those came out to be perfect squares. Something raised to the 1/2 is the same thing as taking the square root of the inside, all right? And we know the square root of 25 is 5, and the square root of 144 is 12, and that's your final answer. Moving to E. So E is tricky because you've got sort of roots within roots, all right? I think the best way to start this one is to actually turn your roots that you see into rational exponents or fractional exponents. So I'm going to leave that 16 on the top and see what I have on the bottom. So let's see. So this is the square root of 8. Now the square root of 8, that's 8 to the 1/2. And then that gets cube rooted. So that also gets raised to the 1/3, that whole quantity. So that's like a power to a power. And here, this is going to be 4 to the 1/4. All right. So power to a power, we multiply. So this is going to be 16 over 8 to the 1/6 times 4 to the 1/4. All right. So now's the point where we're thinking, well, I'm seeing some things where the bases are different. 16 technically is raised to the 1st, and 8 is raised to the 1/6, and 4 is raised to the 1/4, but those are different bases. 16, 8, and 4 are different. But we can do this thing called change of base, where we can try to get a common base across these. And so it's really nice because don't forget that 16 is the same thing as 2 to the 4th. And 8 is the same thing as 2 cubed. And 4 is the same thing as 2 squared. And so what I have here is this change of base allowing me to get everything in terms of base 2. So in the numerator, I have 2 to the 4th. Down here, power to power, you multiply, so that becomes 3/6. And 3/6 is the same thing as a half. And here, 2 times 1/4 is 2/4. And again, that's the same thing as a half. All right. In the bottom, we're multiplying common bases, so we're going to add the powers. This is 2 to the 4th over 1/2 plus 1/2 is 1. So this becomes 2 to the 1st. And then my last step, since I'm dividing common bases, I subtract the exponents. And 4 minus 1 is 3. So this is 2 cubed, which is just 8. Final answer for E. I'm going to pause this video, and then I'll make another one for part F.